Good afternoon, everyone. We're going to have a session today about Jamf Safe Internet. We've got Hernan and Matthias that are going to walk you through some of the newer capabilities. You heard a little bit about what we're doing on device, so this is the deep dive session. I'll turn it over to the guys. There's Q&A at the end. I'm going to be running the mic. For anyone that has questions, stay back, have questions, get them answered. Over to the hosts, or over to the presenters.
Thank you.
Yeah. Oh, you got the mic.
Yeah, all good. I'm mic'd up. Oh, what I don't have is the...
On the table.
Thank you. Well, hello, everyone. Thank you, Suraj. My name is Hernan Romero. I'm product manager for Safe Internet and web protection at Jamf. And I'm joined by Matthias, Matthias Tripp. He's a senior software engineer, also at Jamf. And it's a real pleasure to be on stage here to talk about network security in the education industry and what's happening out there, what we're doing about it at Jamf. And first, I'll be talking about why K-12 and higher education are so targeted by cyber criminals. What are the main threats? And I will do a deep dive into one of the biggest threat actors so we can get an idea of who we're facing. Then we'll switch to what Jamf Safe Internet does to fight these threats in the space of network security. I'll give an overview of the controls IT admins have here so you can get a really good understanding of what you have under control. And before, I'll hand it over to Matthias to go more in depth into the innovative technologies that take network security for Apple to the next level, such as on-device content filtering and machine learning. So, the education sector continues to be one of the prime targets for cyber criminals. A recent report by Checkpoint revealed that education faced a 28% global increase in cyber attacks during the first quarter of 2024 when compared to the same quarter the previous year. And why is that? Well, many schools and universities are using outdated systems and have inadequate cybersecurity budgets. They also hold extremely valuable and personally identifiable information, such as student records, health records, but also just a myriad of financial data and confidential data that you might find very valuable as a cyber attacker. And then we also have an increased number of devices and higher reliance on digital platforms in the education space, which just increases the attack surface for these cyber criminals. And finally, there's just not much leverage that schools and universities have when it comes to certain threats. So for instance, when it comes to ransomware, sometimes the easiest choice for them is to just pay the ransom. So it becomes a very, very attractive situation for cyber criminals to really target those institutions when it comes down to, not being able to continue lessons, having huge disruptions in place. So really something to watch out for. Let's have a look at the usual suspect, which is phishing. Virtually all education institutions are victims of phishing attacks. As you can see there, really, it's just virtually all. Jamf found that phishing is especially risky on mobile devices, which are widely used in schools such as iPads. These attacks are 50% more successful when compared to Macs. In fact, 25% of mobile users clicked on at least one phishing link each quarter in 2023. You miss a lot of key information when you use those smaller devices. So they omit a lot of those details in the UI, which might be crucial for awareness of whether something is phishing or not. And yeah, if it's a mobile device, it's just more likely to be phished. And unfortunately, that's the widest used device in schools. And according to CISA, 90% of all cyber attacks start with phishing, and it's a frequent entry point for ransomware. And phishing is becoming smarter through the use of AI, social engineering, and multi-factor authentication exploits. Moving on to the next one, cryptojacking. So what cryptojackers do is to silently compromise devices to mine cryptocurrency for free. In education, they can slow down networks and disrupt learning. And as computing power is diverted away from legitimate users, it really drains those resources. And cryptojacking is fairly novel, so it's clearly here to stay, as you can see in that graph there. It's just staggering the growth that we're seeing. It exploded globally, reaching more than 1 billion incidents. And yeah, it's just a staggering 659% increase year on year. While we have seen slightly less attacks this year, we still believe that is something to watch out for. So higher education here is the one that's mostly targeted here because they have really high bandwidth networks with a lot of computers which are more like higher power. And it's not uncommon to see campus labs which have been used for cryptojacking. So, on to the next one, and this one is the one that's scariest. It's what keeps everyone awake at night. Is ransomware. It's malware that encrypts important and sensitive data, and also demanding payment in exchange for restoring access. 2/3 of education institutions were hit by ransomware last year, making it one of the most targeted sectors globally. And 40% of these are caused by the existence of unpatched vulnerabilities. The financial impact of ransomware is staggering. The average ransom demand across education institutions is $3.6 million. And on top of that, you have all the recovery costs, which can be above $3.76 million. So this is quite worrying, but yeah, it's one of those things where still 98% of institutions do recover that encrypted data. But what's interesting is that 2 out of 3 of those that have been attacked do it by actually paying have paid the ransom. Like I said, sometimes the stakes are really high. There's a lot of time constraints, and maybe a few days might become millions and millions of dollars lost. So sometimes paying that ransom just becomes way easier. But it's one of those things where you have to take case by case. So even if an institution does pay the ransom, it doesn't guarantee getting the data back. And yeah, this year, like 37%, there was a 37% increase in the amount of time it takes to recover from ransomware. It can take more than a month, for instance. So it's quite an impactful one. And just to kind of get an idea of what kind of threat actor we're facing, we're going to do a deep dive onto Vanilla Tempest. Not sure if anyone here has heard of Vanilla Tempest. It used to be known as Vice Society. So it was born in June 2021 with that name. Then it rebranded, probably as a way to kind of evade once you've been detected. But yeah, they disproportionately target the education sector, but mainly in the US. That's true. And it's probably the most impactful ransomware gang in the education sector. And the ransom demands usually exceed $1 million US. And with recovery costs that we've seen are in the tens of millions. So it's, if it's a school district and there's hundreds of thousands of devices, that becomes quite expensive to recover from. And it really doesn't help that they employ double extortion. So double extortion, what that implies is that they don't only encrypt the data, they also exfiltrate it. So when it comes to paying a ransom, it's not just to get the data back, but also to make sure that that data doesn't leak. How they work, they pay an operator which has ransomware as a service. It sounds kind of consumery, but really what they do, they actually create the ransomware, and then they sell it onto these affiliates or these gangs, as I said, and they pay a monthly fee to use it, or even do some profit sharing in order to really all the parties be able to profit from this attack. So how they usually infiltrate into the network is through phishing. So that's, again, like I said before, is the usual suspect, and is also one of the main ways that ransomware gets in. And a lot of the exfiltration goes through command and control centers that they host somewhere and in the network, and you might not be aware of. And a lot of the things that they do as well on the devices in order to get higher controls in the devices using native tools like PowerShell or SMB. So they're not able to be detected a lot of times, and only you find out too late, so with a ransom note. A lot of times they also dwell, so they will already have found the valuable information. So they probably just make sure that it's something that they find that is a useful amount of information before even looking for a different type of data source. So I believe that the average data dwelling is 7 days. So even when an attacker has actually done the encryption, they have been there for a week at least. So it's not like breaking news. It's something that they've already been there, and they know everything already. So it's one of those that for you have to act fast, because as soon as they do everything in the power, they have already done quite a lot of extensive infiltration. So very carefully, we need to make sure that phishing and command and control servers are blocked, and that's where Safe Internet comes in with network security. So Jamf Safe Internet offers simple but effective controls for IT admins in order to block web threats and mitigate risks at schools and universities. Of course, we should be considered as part of your wider security stack. So you will have vulnerability patching through your MDM, or backups, multi-factor authentication, access controls, endpoint security. So you really need to look at it from a wider perspective, and we're going to look at it as well from this network security space right now. So really, I'm just going to focus on that aspect of your security stack, but you should really look at other parts, because like I said, vulnerability patching is another way where threat actors gain access and also get more privileged controls. And yeah, Safe Internet is really easy to deploy into your devices. It seamlessly integrates with Jamf School, which is great. It's way less steps to do. And it can also be deployed with Jamf Pro. So, and we have multiple MDMs that we support as well. At its core, Safe Internet blocks known host names, IP addresses, and servers that are harmful to your devices. And you're able to prevent phishing, cryptojacking, and malware network traffic, which includes those command and control host names that I was talking about, which are used for ransomware. The policy is enabled by default and controlled by a simple toggle. And while it looks really simple there, behind the scenes is where the magic happens. It's really the commercial-grade network security that Jamf Security Cloud offers. So you're getting that same commercial grade, and we really mean it. We, for instance, have the same threat intelligence, which is meticulously analyzed and enriched by our Threat Labs team. And it uses internal and external sources to make sure we really fully verify that everything is as it should be. It is also powered by machine learning and on-device processing, which Matthias will get more in depth, in order to evaluate the network more in depth. And that's really more in the Apple space for us. We really believe in leveraging Apple native technology and being the best at Apple and getting the best that Apple can offer us. So yeah, really excited for you to hear what Matthias has to say afterwards. And yeah, finally, we have our content rules. Actually, this is the second one. We have content rules. Typically, they're used as categories to block inappropriate content, but they also reduce the risk surface. So for instance, adult gambling sites, sites that include illegal content, those are typically entry points for network malware. So really also trying to narrow down what kind of categories you want to block on your content policy. It's key there to support, have greater security in place. So yeah, double down on that blocking aspect. And yeah, finally now we have the custom rules. So these controls are the same. Which one are you looking at? Sorry. Oh, okay, sorry. Previous one. Yeah, the controls are the same with the option of adding your own rules. They can be IP addresses, host names, and full URLs that you know are malicious. Full URLs can be particularly useful, for instance. So if you know like a Dropbox file that you want to block, but you don't want to block the whole of Dropbox because you might have some resources there that you want to use, you're able to do that, right? You're able to make these rule exceptions in order to still be able to be productive. And that's it. I hope you really get a good idea of what Safe Internet has to offer. And now I'll hand it over to Matthias, who will go more in depth into the security innovations that we're doing for Apple. Thank you.
Thanks. Thank you, Hernan. All right, let's advance to the next slide. Yes, so Jamf Safe Internet protects your end users from against inappropriate content and your network from external threats, and regardless of whether you use Google Chrome, Microsoft, or Apple as a platform. But today, I really want to focus a little bit on one platform in particular, and I spoiled the slide a little bit already, but it is obviously Apple. Here at Jamf, we remain Apple first, Apple best, and it shows. A great example of that is what we call the on-device content filter. It uses Apple's native network extension framework, which is deeply integrated into iOS and iPadOS to analyze network traffic directly on the device. Most importantly, of course, it's privacy by design. Apple made their extension in such a way that it is sandboxed, meaning it cannot leak any sensitive information to the outside world. That's why it's private by design. And last, it has expanded capabilities. We can do things with the on-device content filter that traditional filtering technology cannot do. Well, what does that mean? Let's zoom in a little bit. So most content filters work in a way where each request needs to be relayed to a cloud service. I've got two examples up here. One is relaying it to a DNS service in the cloud, where it will respond with either the original DNS response, or it will rewrite a response to show you a blog page. Or the second example is an HTTPS proxy. And in particular, HTTPS proxies are not as effective anymore these days because, well, most, if not all, websites and apps use encrypted traffic, obviously. And in order to be effective, you need to do things like TLS decryption, which is resource intensive and also can break apps or websites who use technology like certificate pinning. So that's not the way to go. The on-device content filter, it works very differently. Like I said, it's deeply integrated into the OS itself, into the networking stack of the OS, meaning that all traffic flowing in and out of the device will be routed first through that on-device content filter. And there we have the ability to classify the content and look for any threats in there, and apply the policies Hernan was talking about earlier to that particular flow of network traffic, and then make a verdict on it. Is it safe? Is it blocked by the policy, yes or no? And lastly, report on it. Next, privacy by design, and that hooks right into what I was talking about in terms of reporting. So what does it mean, privacy by design? Well, thanks to Apple's semi-sandboxed architecture, we make sure that all evaluation is done. As you can see on the left side, that's the sandbox side of the extension. All evaluation is done in that place. There, we have access to a lot of information. Full URLs, query parameters, and even up to the content of what is being displayed. So in this case, it's a simple example. It streams some HTML, but it could be anything. Thanks to the fact that this happens in the sandboxed extension, we cannot leak any of this information to our reporting servers or write anything to disk where a malicious actor could extract that information. Instead, once the evaluation is done and a verdict has been created, we will route that information to the non-sandboxed extension, where Apple automatically, and that's why it's private by design, automatically strip down all the sensitive information that might be in there. For example, a query parameter, which might show you what a student has been searching for on the internet. And last but not least, I want to talk about expanded capabilities. So what do I mean with that? Well, Hernan touched on it a little bit already with the custom rules. But unlike other filtering techniques like DNS, we can filter on full URLs, meaning we can inspect it up to the path, including query parameters, even a hash value in there, and even the content of a website, because we are working in the sandbox part of the extension, and it's at that point, it's already unencrypted traffic. Additionally, we can filter on IP addresses. This is also quite unique. We can filter on IPv4, IPv6 addresses, but also entire ranges or even subnets. And last, we can filter on apps. And this is also pretty cool. Thanks to the fact that we are embedded into the networking stack of Apple, each network flow gets some kind of a label saying this process or this application has originated this request. So say you open the Facebook application, it loads your news feed. That API call that's being made is being labeled like the Facebook app, com.facebook.whatever, is making this request. And we can use that information to also, again, filter. So let's zoom in a little bit on that. Well, a little bit background information. Apps can also be a key attack vector for malicious actors, of course. This is not only true in enterprises, but definitely also in education, where devices, for example, are taken to home when the school allows it. And some examples of risks that app can expose are permission and data access controls that could violate a school's governance risk or compliance requirements, or it contains a known CVE, or even a zero-day vulnerability that has been, for example, detected by our threat labs or our machine learning. Well, with Jamf Safe Internet, we can easily manually block any of these apps we know. It's really simple. You just go to Policies, App Blocking, you enter one or more bundle identifiers, and you click the block button. It's that easy. And every part of traffic that has that label of that application will automatically be blocked right on the device. But there's one more thing I would like to talk about in terms of expanded capabilities. And we're really excited to give you a sneak peek of what we've been very hard at work this year, and that is on-device phishing detection. Well, let's dive right in. What is on-device phishing detection? Well, phishing tactics are constantly evolving, with new sites and methods appearing faster than a traditional database can keep up with. There are loads of already known URLs of sites that contain phishing attacks, but new ones are appearing on a daily basis, maybe even on an hourly basis. The on-device phishing detection machine learning model can recognize patterns and characteristics of phishing websites without relying on those predefined lists, providing a proactive protection against those threats. Running those models on device in the semi-sandboxed architecture, like I talked about, allows model inputs otherwise unavailable. For example, we can feed it with a path or a query parameter, or even, like I said before, the content of a website, where you can specifically scan for certain keywords or certain characteristics. And this is very powerful. It utilizes the neural engine that can be found in all modern Apple devices. Apple provides us with a framework called CoreML, where you can, well, basically feed a model or put a model on the device, feed the features in, and it will give you a verdict. This sounds very easy, obviously, but it is a lot of work. So Threat Labs team has been hard at work creating these models for us, and we've been hard at work in embedding it into our application. And again, this all runs on device, which is super unique, which makes that it's super fast in evaluation because it runs on those highly efficient cores Apple put in their machines. And even better, it won't affect the end user's performance. Well, How can I say that? First of all, it has been trained with over 500,000 data points already, and that number is probably already outdated. We're constantly retraining this model to be more effective and more efficient. The latency of when the moment you put in a specific flow of network data to be evaluated to the point where we get a verdict is 0.04 milliseconds. That's extremely fast in the sense of no end user will ever notice that this is happening, but there's a lot happening in the background, obviously. And so far, we reached around 90% precision. That means most predictions we flagged as, yep, this is probably phishing. We're actually phishing after manual validation. That's a great result, but we can do better, obviously. So we keep retraining the model with data we gather, and it will get better over time. So this is a feature that's coming up, but I can tell you already how to enable it. Well, in true Jamf fashion, there are just a couple of steps. You go to the policy, you select phishing as I want to block it, obviously, and literally there is no step 3. All the rest of the magic will happen on the device in a secure environment without affecting the end user experience. So we're really excited to bring this to you, and like I said, we're constantly evolving this model, and it will get better over time, but it's already pretty great. All right, thanks for this. I hope I was able to give a little bit of an insight in what's going on under the hood, and with that, I want to hand it over to Hernan to give a quick recap of what we've learned today, and then there's time for some Q&A.
Thank you. Yeah, so thanks a lot, by the way. That was super insightful. Before finishing, I wanted to quickly go through what we've learned. First of all, it is clear that the education sector is targeted, and it's unprecedented the amount of cyber criminals that are targeting the education sector. And it can be phishing, it can be cryptojacking, ransomware, and there really are no signs of that stopping. You've seen how Jamf Safe Internet can prevent you from falling victim of those as part of your wider security stack. So right in the network security as part of that wider stack. And finally, we're able to leverage Apple's most secure frameworks in order to make it extra secure, actually making it our most powerful platform that we support, and really focusing on those on-device processing features as well as Core ML, which Apple offers us. So yeah, I think we heard it today, when Apple innovates, we celebrate, but we also innovate based on that. So yeah, thank you so much. And now we'll open to Q&A.
Thank you, guys. Questions? That was super cool for me to just get it. So thank you. I was learning.
Hope you learned a couple of things as well.
Wow, you guys were crystal clear. Like,
yeah, I think that's it.
Knocked everyone dead.
No questions? Great. Well, thank you so much, everyone. If you have any questions after this session, feel free to reach out to either of us. You can just grab us if you see us around, or otherwise you can find us on the JNUC app as well. So I think there's some features there where you can find the contact details. So yeah, thank you.